The To-Do or Teamwork Makes the Dream Work is a project of the SciTech Mathematical Society, the official mathematics club of Santa Rosa Science and Technology High School. It is a project that aims to provide support to high school students in their respective mathematics subjects. This project consists of distribution of reviewers by grade level and posting of tutorial videos on YouTube. The topics in the tutorial videos are those that are requested by the SciTech students that responded in a survey given by the club, while the topic in the reviewers covers all the topics discussed in the quarter. The reviewers are only exclusive for the SciTech Mathematical Society club members.
Hello people, welcome back to another SMS Project 2 Teamwork Makes the Dream Work YouTube tutorial video. I'm Jasmine Pacete, SMS Grade 9 representative, and for today's video we will be talking about another requested topic, which is the trapezoid. But again, before we start, if you haven't seen our previous Geometry 9 discussion, here are the topics discussed on it. So if you need help on this, just browse around this channel profile and you'll find it. And yeah, with that, let's get on with our discussion. Here are our objectives for today's discussion. First is to be able to prove theorems on trapezoid and then prove theorems on isosceles trapezoid. So now, what is trapezoid? Well, a trapezoid is a quadrilateral that has only two sides that are parallel. Interesting, right? Now, for the theorems, on trapezoid, we have one here which states median of a trapezoid is parallel to each base and its length is one half the sum of the lengths of the bases. Take note of that. Then now for the theorems on isosceles trapezoid, we have three. The first one stating the base angles of an isosceles trapezoid are congruent. And then on theorem 2, we have opposite angles of an isosceles trapezoid are supplementary. And on the last, which is theorem number 3, we have the diagonals of an isosceles trapezoid are congruent. Okay, as always, please take note of this and also the one on trapezoid because it will be needed in our exercise time, which is right now. Ready your pens, paper, and brain. And let us begin. For our problem number 1, we have here in trapezoid tens, EN is parallel to TZ, C and D are the midpoints of TE and NZ respectively. And so if En is equal to 17 and Tz is equal to 49, what is the measurement of CD? Okay, to answer, we'll need the formula by the trapezoid theorem, which states median of a trapezoid is parallel to each base and its length is one half the sum of the lengths of the bases. Meaning here, CD will be equal to 1 half multiplied by En plus Tz. Then we substitute our given values. We will now have CD is equal to 1 half times 17 plus 49. And first, multiplying 1 half by the sum of 17 and 49, which is 66, will give us the measurement of CD that is equal to 33. And problem solved. Now moving on for our second problem, we have here in trapezoid rays, AY is parallel to RS. Now suppose angle Y is equal to 78 degrees. Now find the measurement of angle A, angle S, and angle R. Okay, to solve this, first we find the measurement of angle A. And so given that race is an isosceles, then angle A and angle Y are congruent basis angles, and the measurement of those will be equal to each other which means A is equal to 78 degrees. And angle A found. Now, let's find the measurement of angle S, wherein we can analyze here that angle Y and angle S are consecutive interior angles formed by YS intersecting two parallel lines. Thus, they are supplementary. So, to get S, we use consecutive angle supplementary to 180 formula. That is, the measurement of angle S is equal to 180 degrees minus 78 degrees. That is equal to 102 degrees. And there we go, angle S found. Now, we head to solving for the measurement of angle R. So for here, we know that angle R and angle S are a pair of base angles. Thus, they are congruent by isosceles trapezoid theorem 1 that states base angles of an isosceles trapezoid are congruent. Therefore, the measurement of angle R is equal to the measurement of angle S, that is equal to 102 degrees. And there we go. Angle R found. And problem number 2 solved. And so head to our next problem. We have here in the same trapezoid rays, if angle R and angle S are right angles and RA is equal to 11 centimeters, the length of the mid segment JK is 17 centimeters. Sketch the trapezoid rays and its mid segment, and then find AY of trapezoid rays. Okay, to answer, we first of course sketch, and you can see that on your screen. And then to solve, we first let x be AY, then we'll need the formula by the trapezoid theorem, which states median of a trapezoid is parallel to each base and its length is 1/2 the sum of lengths of the bases. Meaning here, JK will be equal to 1/2 times the sum of RA and AY. Then we substitute our values in the formula, and that will now be 17 is equal to 1/2 times 11 plus x. Then to begin solving for x, we first multiply both sides by 2, and that will equal to 34 is equal to 11 plus x. And then now to get the value of x, we subtract 11 to both sides, which will therefore give us x is equal to 23, or ay is equal to 23. And there we go, problem 3 solved. Now for our problem number 4, we have here in isosceles trapezoid soup, OU is parallel to SP, and so if the measurement of angle SOU is equal to 5x and the measurement of angle SPU is equal to 4x, find the value of the measurement of angle OUP. Okay, to answer this, we first analyze and I can say that we know that in an isosceles trapezoid, opposite interior angles are supplementary. That is by its second theorem, which means the measurement of angle SOU plus the measurement of angle SPU will be equal to 5x plus 4x, which if we simplify will be equal to 9x. That is equal to 180 degrees. Thus, if we divide those to 2, x will be equal to 20 degrees. And now, since soup is isosceles, the measurement of angle OUP is equal to the measurement of angle SPU, that is equal to 4x. And then we substitute the value of x to 20 degrees. We'll now have 4 times 20 degrees. And that will be equal to 80 degrees. Therefore, the measurement of angle OUP is 80 degrees. And problem 4, solve. Now, for our fifth problem, we have here prove that the quadrilateral below is a trapezoid, then prove that it is not an isosceles trapezoid. Okay, to answer this, we first solve for the slopes. That is, OC is equal to 6 minus 4 over 4 minus 0 is equal to 2 over 4, or simplified form is 1 half. Then for LK, which is equal to 1 minus 0 over 2 minus 0, that is equal to 1 half. And as you can see, OC and LK are the same. Therefore, they are parallel to each other. Now, next is for the slope of CK. That is equal to 1 minus 6 over 2 minus 4 is equal to negative 5 over negative 2. And then for OL, which is equal to 4 minus 0 over 0 minus 0, that is equal to 4 over 0. And here, as you can see, CK and OL are not the same. Therefore, CK is not parallel to OL. And with that, we are now given that only one pair of sides in quadrilateral lock are parallel. Therefore, it is a trapezoid. Now, with that given information, we compare the lengths of leg of OL and CK, wherein CK is equal to the square root 1 minus 6 squared plus 2 minus 4 squared, that is equal to the square root of 29. Then for OL, that is equal to 4 minus 0 or equal to 4. And as you can see, legs OL is not congruent to legs CK. Therefore, lock is not an isosceles trapezoid. And there we go. Statements proved. And now on to our last problem. For problem 6, we have proved that the area of a trapezoid with parallel bases B1 and B2 and the height h is given by the formula area is equal to 1 half times B1 plus B2 times h. Okay. To answer this, first we duplicate the trapezoid and we call this A prime, B prime, C prime, and D prime. And then we rotate the trapezoid by 180 degrees and place that beside the original trapezoid as the one you can see on your screen right now. Then, since angle ABC and angle B prime, C prime, D prime are supplementary, and angle BCD and angle A prime, B prime, C prime are supplementary, then they are linear pairs. Also, angle ABC is congruent to angle A prime, D prime, C prime, and angle BAD is congruent to angle B prime, A prime, D prime. Hence, we form parallelogram AD, A prime, D prime. And now, the area of the parallelogram is B1 plus B2 H, and is also twice the area of the trapezoid ABC. Hence, the area of AD, A prime, D prime is equal to 2 times the area of ABCD. Therefore, the area of ABCD is equal to 1 half AD, A prime, D prime, that is equal to 1 half the sum of B1 and B2 times H. And there we go. Problem 6 solved. And that's it. Thank you once again for watching and listening. And I hope all of the videos helped you to finally uh, overcome your struggle. And that's it. Thank you. Bye.